So today we're going to do 9 questions from a unit test that deals specifically with logarithms. And you're like, oh my gosh, logarithms. Now, this is going to be very, very easy if you just follow the procedure. Now, let me tell you something. We're going to do a quick, before we do this problem, we'll do a quick little review. All right? Does anybody know what 2 to the power of 3 is? 8. Because 2 times 2 times 2 is 8. Okay? Now, in a logarithm, this is how you would write the logarithm. This is exponential. This is a logarithm. So in your journal, just write this down. Write down. This is called exponential form. Okay, exponential form. And this is called logarithmic form. All right. Now, I want you to see how I can change it from exponential form to logarithmic form and go back and forth. Check this out. We're starting at the 2. We're going to go around the world. 2 to the power of 3 equals 8. So what is the reverse operation of addition? If I said what's the reverse operation of addition, you would say subtraction. What's the reverse operation of multiplication? Division. What's the reverse operation of squaring something? Taking the square root of something. So what's the reverse operation of exponential functions? Logarithmic functions. That's what I want you to be understand. Like, why is it there? It's to help you be able to solve exponential problems and work your way backwards. Okay? So we're going to be doing that today. Okay? So hopefully you have a better understanding of why is it there today than you did yesterday. Okay? So right out, let's take a look at our problem. Ours says what? Log 1/3 81 equals, I don't know. Let's just put an X there. Okay? And we're going to go around the world. We're going to set it up as an equation. So we're going to say 1/3 to the power of X equals 81. So I want you to write this down. 1/3 to the power of X equals 81. Does anybody know what 3 to the power of 1 is? 3. Does anybody know what 3 squared is? 9. 3 cubed, 3 times 3 times 3 is 27, and 3 to the power of 4 is 81. 3 to the power of 0 is 1. 3 to the power of negative 1 is 1 over 3. 3 to the power of negative 2 is 1 over 3 squared, which becomes 1 over 9. 3 to the power of negative 3 is 1 over 3 cubed, which becomes 1 over 27. I want you to see the pattern so your brain understands how negative exponents work. All right? Well, remember, if you want to make a negative exponent positive, just shift it down underneath. You've learned that before. So what is actually 1/3? How could I write 1/3? 3 to the power of negative 1. How could I write 81 as a power of 3? 3 to the power of 4. So if I have 3 to the power of negative 1 times x, remember, what's power to a power? You're allowed to do what? Multiply those together, and you get 3 to the power of 4. What matches now? The 3's. So if those match, those have to be equal to each other. If the bases match, those have to be equal to each other. So if negative x equals positive 4, what do you think x would have to equal? Negative 4. So what does that mean? Check this out. Ready? What if I said 1? Hold on, I got to clear this out. 1 divided by 3, close parentheses, raised to the power of negative 4. What's that equal to? 81. So what is my answer going to be? Negative 4. Okay? Oh, by the way, for those of you who aren't concerned about any mathematical concepts, yeah, I just don't care because I really have no motivation to learn anything in my life. I just want everything spoon-fed to me. Okay? So that's how you spoon-feed the answers. Now you understand what the computer does for you. So today is about learning not everything you need to know about logarithms. Today is about learning what the computer can do for you and what it's doing for you so you have a better understanding of how the world works around you. Okay? So what am I going to type in there? Okay. So guys, this one it's very hard to see, but I'm gonna write it down here where it's a little bit easier. It's going to be log base 4 of m. I got to pause the video because this is times log m of 20. Okay? So there's this thing called the change of base rule, and I want you guys to write this down in your journal, okay? So put change of base. Okay, so if we have a logarithm, and I have any base, base b, okay, and I have that of a, that will equal the log of a over the log of b, okay? Now, these could be any, I'm just going to put base 10 and base 10 because we're in a base 10 counting number system. Okay, but if you ever go to the graphing calculator and you're wondering, and I'll give you a chance to write this down real quick before I move on. So write that down. That's going to be pretty important. Now that 10 could be a 2, a 3, a 4. The base has to be big. By the way, the b value, the base right here, has to be greater than a 1. Okay, it's like anything that's bigger than a 1. Base 2, base 3, base 4, base 5. It could be a base 1.2 or 1.1. Okay, everybody have that? Okay. So does everybody see this log button right here? This is actually a log base 10. So even though you can't see it, the number that would be right here, that I put a 1/3 right there, that would be actually log base 10. So if I put like 100 there, 10 to the power of what is 100? 10 to the power of what number? 10 to the power of what number is 100? 10 squared, because 10 times 10 is 100. Okay? So right here, if I said log 100, what are you going to get? What's it going to spit out? A 2, because 10 squared is 100. If I said log 1, 10,000, how many zeros do you see? There we go. So look. So what does this mean? This simply means, even though you can't see, this is called a common log. That's base 10, even though you can't see it. So if I were to do the around the world method, 10 to the power of 4 equals what? 10,000. So that's kind of how it, have a better understanding of at least how it works. Okay? Right now I'm giving my students kind of a crash course in logarithms just to give them an understanding of that before they leave high school. Okay? All right. All right, so let's go back to our problem, which is, hold on. Oh, right there. Let me go back to my problem real quick. And there we go. Okay. So we're going to use what's called the change of base formula. So check this out. I'm going to put log of m over the log of 4. So I used the change of base, put the a over the b, and I'm writing the log of, what do you think I'm going to put on top? 20 over the log of, see, I put this over this over this over this. Now, interestingly, what happens to cancel out? So now what do I have? I have log of 20 over the log of 4, but if I use the change of base formula, let's put it back into the what? Back into this form. Boom. There it is. So we went from this to this, back to this. I'm going to pause the video to give people a chance in my class to write them down, because that's a pretty important concept. All right, so I'm going to choose answer choice D. I'm going to fast forward through some of my notes so I don't. Okay, let's take a look at this one. Now this one's going to be really easy. Okay, but listen, it's easy because you actually have the calculator that can do this, but not all calculators have alpha window number 5. So what we're going to do is I want you to see how the change of base formula actually works for a regular graphing calculator. I want you to take the log of 5 over the log of 8, and we're going to get an approximate decimal. So we're going to do it the old school way, then we'll do it the new school way, okay? So the old school way is to do what? Log of 5 over log of 8. So you just put log of 5 divided by the log of 8, like that, okay? Now you could do alpha y equals enter and do the log of, wait, did I do it right? Yeah, okay. The log of 5 over the log of 8, like that. But now we have this cool little shortcut, alpha window number 5. And what gets you to put right there? An 8 and then a 5. But does everybody see that these are all the same? Yeah. So this is kind of the new technology, that you had to know the change of base formula for the old technology. Okay? So we're going to put to the nearest, what, thousandth? So this is to the nearest thousandth. So what do I have to do with that 3? I got to round it to a 4. So my answer is going to be 0.774. And you got to make sure you know how to round. If you don't know how to round, you will get math problems wrong that you should have gotten right. Okay? And I don't know about you, but that always ticked me off. Okay? 0.774 is what I'm going to type in. Okay? Would you guys agree that that's pretty much is a gimme? Okay? Okay, so this is where we actually learn how logarithms work. Okay? So right now, what we're going to do is they've given us this exponential problem. Okay? So they've given us this exponential problem. And in order to solve this exponential problem, we have to know how to use logarithms. We're going to show you guys how to use logarithms. So check this out. The very first thing after you write that down is you're going to divide both sides by 11. And so these are, hold on, I got to pause my video. Okay, that's, yeah, it's very 5-2. All right, power went out, power's back on. Hopefully this is still working. So these 11s cancel each other out. You're probably wondering why I paused for so long, because the power was out. Now, guys, I'm going to leave this. Hey, I'm just going to leave this as 20 over 11. Okay? Now, this is the part that's going to be confusing to start out with because you're like, you have never seen how logarithms work. But do you guys see where the t is right there? That's up there in the exponential realm. It's not down here. So we got to get this guy to come down. Like, how do we do that? That's where the power of logarithms comes in. So what I want you to do is I want you guys to write this down. Put log base 10 to the power of 5t equals log base 10 parentheses 20 over 11. I'm going to highlight what I applied to both sides because I really haven't changed anything. Whatever you do to one side, you have to apply to the other side. So notice, what did I keep? I kept what? 10 to the power of 5t, and I kept the 20 over 11. That was somebody's spam risk was calling. Now, I want you guys to understand that what happens here when you apply a 10 to a power, basically log base 10 to 10, it just cancels out and all you're left with is a 5t. So I'm going to show you how this works, okay? So check this out. If you had the calculator and you applied log and you put 10, look what it equals. It equals a 1. Now if you're wondering what I did there, alpha window number 5, if I put a 10 and I put a 10 right there, that equals a 1. These mean the same thing. So a lot of times you'll see me apply the common log and you won't see me write a base 10. I just want you to know that a 10 is there whether you see it or not. Okay? Now, this equals, I'm going to rewrite it easier. Notice, what did I removed the 10, but I want you to understand the 10 is still there. You just can't see it. My last step is to divide both sides by 5. Everybody, this is my answer as a logarithm. That's my answer as a logarithm. Now watch what happens when I type it in the calculator. So all I want you to do right now with me is go to your calculator, type in a log, put 20 divided by 11, press enter, divide that by 5. You guys see that 0.0519? I'm gonna write 0.0519. 0.0519, and I'm gonna look up here and we're gonna see what it asks for. Nearest thousandth, so I'm gonna put 0.052. So right here, I'm gonna put 0.052. And what am I gonna write as the solution of a logarithm in base 10? I'm gonna write log. I'm gonna put 20 over 11, and that's all being divided by a 5. So you already have that in your journal. I'm just going to show you how to type it in. So do you guys see the original expression right here? Check this out. It was a what? It was 11 times 10 to the power of, so I'm going to put 5 parentheses t. Would you guys agree that's what we found for t? Okay, let's put it in there. Let's close it. I'm going to press enter. What's it equal to? What did we want it to equal? 20. That lets me know I got it right. Okay, so I'm going to need you guys' help because I probably have a hard time. What, is it 0.052 right there? Okay, here we go. 0.052, that's the near. Let me check. 0.0519, so 0.052. Okay. 0.052. Yeah, okay. And then for the other one, I need to write, see the log right there? Put a little parentheses. 20 divided by 11. Go on the outside, hit divided by, and put a 5. Okay. Now, if you wanted to, you could actually put 1/5 out in front, like 1/5 times it, if you wanted to do 1/5 times it. Okay? All right, let's take a look at this. All right, like, oh my gosh, how am I supposed to do this? So right now, I'm going to give you guys an opportunity to just write this table down. Go ahead, just write. I'm going to pause the video. You guys just write down the table, okay? That will help you guys with the problem. So right now, what we're going to do is I want you guys, I'm going to go to Desmos real quick. It won't take long. It's going to go to Desmos, okay? And I'm going to write y equals 2 to the power of x. And then here I got to go to my functions. Let's see here. Let's go miscellaneous. Put log. I'm going to put 2 and put an x right there. Okay. And I'm going to put y equals x. These are actually what's called inverses of each other. So an exponential function's inverse is a logarithmic function. And so when we go to the table, I want you guys to see them. It's kind of cool. If we go to this table right here. All right, so does everybody see that? That says a 1 and a 2, and that says 2 and a 4, and that says 0, 1. This says 1, 0, 2, 1. Look what happens when I put a 4. 2. Interesting. So if I put a 3 here, it becomes an 8. If I put an 8 here, it becomes a 3. So the whole purpose of me showing you this is to help us with this problem and show you how easy it is. Okay? Does everybody see? This is a what? -1 and a 0.5. This is 0.5 and a -1. This is a what? 6 and a 2.585. So that's 2.585. So that would have to be a. So you're not doing math. You're just understanding that logarithms and exponential functions are inverses of each other. See what I'm saying? So I just want to make sure you knew that before you did this problem. This is just about, I'm not trying to make it difficult, I'm trying to make it easy. So if that's 1.585 to a 3, then 3 should go to a what? 1.585, and that's all I want you to put in your journal, because you're going to get a question like that, and it's not hard. You just need to know the pattern. So right now, I'm going to put a 6 and a what? 1.585. It's kind of hard to see. 4 times 5 to the power of -6t equals 2,000. Give you a chance to write that one down. All right, first thing we would do to solve this problem, first thing we do is divide both sides by the number that's out here in front, 4. That's first step. So what is 2,000 divided by 4? Is it 500? Okay, so far so good. All right. Now, interestingly enough, what did we have to apply to both sides to get rid of a base 10? Log base 10. So what are we going to have to apply to both sides to get rid of a log of base 5? Log of 5. So we're applying what's called a log of 5 to both sides. So I want you to understand, I'm not changing any values. I'm just applying this to both sides. So what happens when you apply log 5 to both sides? What happens to all of this? Everything disappears except for the -6t. And then you just divide both sides by -6, and you're done. Okay? So your answer is going to end up being C. Now it says negative log, okay? But that negative can go up there if you want it to go up there in the numerator. You guys got that written down? Good. All I want you guys to do is write this down. Like, I cannot see that, so I'm going to write it down bigger so that you guys can see it. All right? That's why I got to walk a little bit closer to my screen to be able to see that. So I got to get a little closer. Wow, I think it's 25. I don't know. I'll have to go to my computer screen. Hmm. All right, 25. There we go. So let's go back to, so that's t to the power of, sorry, 2 to the power of t over 25. Okay. Now, it says, since 2010, the town of Fall River has been experiencing a growth population. Okay. A growth in population. Now, the relationship between the elapsed time t in years since 2010 and the town's population p of t is modeled by this function. According to the model, what will the population of Fall River be in 2020? Well, let's see here. What's the gap between those? 10. So I'm just going to plug in a 10. See if that works. So I'm going to take 3, 6, 8. I'm going to clear everything out, so we're just focusing on that. 3, 6, 8, 0, 0 times 2 to the power. I'm going to cut parentheses. 10 divided by 25. So it looks like we're up to what? 4, 8. I'm going to write that down right there. Look back at the problem. It says to the nearest whole number. All right, so the nearest whole person. So put 4, 8, 5, 5, 8. 4, 8, 5, 5, 8 is to the nearest whole person. So this one, all I do is just plug in a what? Plug in a 10. 4, 8, 5, 5, 8. 4, 8, 5, 5, 8. Rewrite the following in the form of log C. So this is the last thing we're going to do today. I want you guys to do something with me real quick. All right, so the first thing we're going to talk about is this concept called log of A plus log of B, and that equals the log of A times B. So the log of 2 plus the log of 4 will equal the log of 8. The log of 20 minus the log of 2 actually equals the log of 10. Because if I have the log of A minus the log of B, that actually equals the log of A divided by B. There are 3 exponent rules: the product, the quotient, and the power. There are 3 logarithmic rules. This is the product rule, this is the quotient rule, and here's the final rule, the power rule. Okay? So if I have, I'm going to put m log b of a, that will equal log b a to the power of m. This is called the power rule. So the power rule allows you to take this exponent and move it back and forth. This is called the quotient rule. Fine, I'll put it over here. Or not. Fine, I won't put it there at all. Stupid board. Put it over here. That's the quotient rule. This is called the product rule. When you add, you get to multiply these together. When you subtract, you get to divide those together. And the power properties, I'll box them in so you can kind of see them individually. We have this rule, we have this rule, and then we have the power rule if you wanted to put those into your journal. So right here, we can just take the 20 divided by the 5, and we get log 4, and you're done. Okay? So you just need to know the 3 different rules. I don't know whether you're just going to have sum, product, or power rule. I went over the 3 rules because there's 3 of them, and that's it. So put a log of 4. Okay? So rewriting. We're going to rewrite this, and we're going to rewrite this. This right here is written like this. Because 10 to the power of 2 equals 100. This one is already set up for you. Just go around the world. 5 to the power of negative 3 equals 1 over 125. Alright, so what I'm going to do is I'm going to go ahead and finish this off right here. I'm going to write right here. Let me look real quick. Log $100 equals 2. Log $100 equals 2. And right here, I'm going to write 5 to the power of negative 3 equals 1 divided by 125. All right? That's it. And that's a whole unit test done from beginning until the end.